Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem. Today we want to again continue our conversation about free fall, but now we want to do it in the mathematical sense. We're going to do some mathematical problems. So free falling, something is falling in the presence of gravity, and it's working by itself. So let's do a sample problem. So you got a dude, he's going to drop a rock off of a cliff. Let's say the cliff is 100 meters. So now he's just dropping it. He's not throwing it down. There's no extra velocity or any of this kind of a problem. So if you think about that, let's write down our variables. We know that if he's just dropping, the V initial, or V1, is 0 meters per second, right? V2, we're going to say, what's the V2 when it hits down here? Because the ball's going to get faster and faster. We don't know that, do we? Well, we know acceleration in our equation. That's just, now watch this, it's negative 9.8 meters per second squared because it's downward. Gravity always goes down. We learned about that number in our last video. We know our distance, or let's say y initial equals 0 and y final equals negative 100. If we're going to say this is the 0 and this is the 100. Sometimes, by the way, I might reverse that. Let's do that. I prefer that. I think the bottom, let's say the final is 0 and then the y initial is 100 meters, right? So the question you often are asked is what's the time and what is V2? So we want to solve for both of those, and so which one should we do first? Let's do V2. Now, remember there are three kinematic equations. Now, we wrote them in terms of x, but you can always say V1, right, V2y squared equals V1y squared plus 2 times, and the next equation was AD, but we're going to say and make that a G times, if actually y. It's technically delta y, the change in y. But I know my initial velocity, or V1, that's equal to this, that's 0 squared. V2, we'll say V2 squared, that's what we're solving, is, plus 2 times G times 9.8 times, and we just say 100, right? It's actually, this is negative 9.8, and he's losing 100 feet. Oh, because we can't have a negative square root. So this is just going to be, let me multiply that out, equals 1960, and that's V2 squared. So find the answer, I'll just take the square root, and I get V2 equals to 44.3 meters per second. So if you drop a rock off of a cliff and you ignore air resistance, it will land with a speed of 44.3 meters per second. That's pretty fast. But what about t? What equation would you use to find t? I think I would use equation 2 as we've written it in our class. We can say V2 equals V1 plus AT, right? At V1, that's 0, right? We have that here somewhere, right? And we now know A. A is always going to be the same on the Earth. By the way, if you're on Mars, it's a different number, all right? But on the Earth, and we'll just say 9.8 times T. And V2 we calculated here, so that's 44.3. The 0, of course, cancels, so divide both sides by 9.8. So time is, I get 4.52 seconds. So if you drop a rock off of a cliff and there's no air resistance, it'll take 4.5 seconds to land, and it'll have a speed of 44.3 meters per second. Ultimately, guys, you're going to use the three equations, right? This is equation, I'm calling this equation 2. This is equation 3. And then the master equation, if you recall, is, I'll put it in terms of y now. Y equals y initial plus V1y times t plus 1/2, and that's AT squared, but in this case, the A becomes a G, and it's going to be negative 9.8 all the time. So actually, if you work that out, that'd be minus 4.9 t squared, because 9.8, half of that is 4.9. So you could actually smush it down that way, and that'll help you solve problems. And sometimes in this question, we didn't have to use this equation. Sometimes you may want to use this equation too. That's free fall. You're going to do lots of problems like this, and I'm going to ask you to manipulate the variables, but remember, there's three equations. This is equation 1, equation 2, equation 3. As a note, in my comp book, I put them in the front of the comp book because I just want to have a quick reference to those equations, so I don't have to keep looking them up like you may want to. Hey, Houston, no problem. We'll see you in class.